Hello and welcome back to module number 9. The main subject of this module is going to be t-test, and we are going to talk about what is it the t-test means for us when we have independent means with regard to the deduction of the population means. But I would like to start something that I did not do quite well, and some of you asked me via email. What is the idea of correlation versus regression, and why are we making a distinction between correlation and regression? So I will try to answer that. It is not the main focus on this module. The main focus is the t-test and how can we apply the t-test with regard to the mean. But let's go back a little bit and try to understand what is the correlation versus regression. So correlation is the idea that of a measurement of the strength of the association between two variables. So correlation is not only occur with the strength of the relationship, but there is no causal effect that can be implied within correlation. In comparison, regression analysis is the use of two variables, dependent variable versus the independent variable. And the dependent variable, the variable we wish to predict or to explain, versus the independent variable is the variable used to predict or explain the dependent variable. Very important distinction between correlation and regression. So in correlation, we often use correlation coefficient to measure the strength of the linear association between the two variables. So the best way to look at them is as we learn, is about person production moment correlation in a form of correlation coefficient. In comparison, regression analysis is the idea require interval and ratio data only, which means it's quite high level of data. And so we are trying to see if the data model that we have can fit into our regression model. The reason is that regression analysis assumes that there is a linear relationship. And so if that case, we can see that type of relationship in the form of a graph, negative, positive, or none of the above. And the idea here is that it can be positive relationship, and it can show us that the idea that a line in the graph can describe for us where is the true relationship or association between the two variables, the dependent variable versus the independent. And they are always fall exactly on the line that is zero when you prefer analyze or try to make a perfect relationship between the two variables. So things to remember about regression: it is association, and it is the needs of the independent, the measurements of the independent versus the dependent variables at time. And so in this case, that's what we are trying to measure. The regression table is the idea that it is how do we display it and what does it really mean. So regression coefficient is the scope of the regression line and tell you what is the nature of the relationship between the variable is. So much of it is the idea, again, as you can see, I'm repeating again and again about the independent versus the dependent variables with that regard. Persons R is one of the key formula for us to measure those relationships. So it is a scale that is usually -1 to +1, where the 0 is no relationship, no linear relationship between the two variables. We also have R square, and R square again can help us to adjust what is the level of example education versus the independent variable is the income. And so if we will measure that, we will be able to have adjustment. We will see that in R, and how can we generate that in R. But this is later on. This is not for today's module, which is not the the t-test. I just want to make sure that we are on the same scale with that regard. So again, we have some variables that we need to do with regard to regression analysis and how to apply that. Those ideas, part of what we will learn about NOVA, and how can we apply NOVA when we are going to have a p-value value that we're going to scale in order for us to measure that, and how we be applied. And when we compare two variables in regression analysis, how do we do that? So the issue that I want, the main slide that I want you to look at is the following slide: single versus multiple regression, and what is the difference between them, in order for you to understand, in order for you to comprehend what is the idea of single regression versus multiple regression, and how do we apply multiple regression. This is called the regression analysis, where we have more than one variables. And in example, sex discrimination in wages, and this is a very hot topic in today's environment. And so again, entry level skills, education are part of the variables that we often use in order for us to scale it, in order for us to evaluate them, in order for us to report about the multi-regression analysis, in order for us to do that. So we have a model, and this model can be changed based on what we will learn about creating your own model. This can be changed, but the issue is, again, the comparison between two variables that can have multiple sub variables that support that. So the output, the predictions, and in R, it's quite simple. And again, this is why I love the R so much, is the idea that in this case, the linear regression in R is called the IM function, which is a linear model. So in multiple regression, in this case, I can write my own formula, and I can say that I have y, and I have x1, x2, x3, and my data equal my data, and I can give it a little bit more result with regard to coefficient, fitness, and values in order for us to do that. But again, I want to go back to our main subject of today's module, and which is the t-test for independent means. And we're going to go back a bit. I hope I didn't get you confused, but I want to go back to t-test. So what is the main use of the t-test? I will try to answer that today. I will try to answer also how the distribution of t related to the unit of normal distribution. What is the z-test has to do with the t-test, and what is the standard error on the difference between the means, and what is the influence of the factor influence its size. So background. The t-test is used as hypothesis about the means when the population variance is unknown. So it's closely related to z when we have unit of normal. And it developed by Gosset in 1876 to 1937. We do not know exactly, but what he tried to do is to measure beer. And the idea was that he came up with three variables: simple sample, independent sample, and dependent sample, in order for him to develop the idea of t-test, but it's also known as a student test. So what does it T stand for? T is the idea of a simple sample T when we have only one group. When we test against the the mean of the hypothesis. The independent sample T, we have two means and two groups, and the dependent T has two means. So either of the sample of both group or the people are related, husband and wife, left hand versus right hand, hospital patient and visitors. A simple sample z-test where we have a larger sample. The n, the capital N, is bigger, is smaller than 100. So we can use the z-test to state a hypothesis about the mean. And this is the formula, and this is how we calculate that. The t distribution is the population variance when it's unknown, and the sample size is too small for us to apply that. So the t distribution is short, but it is the issue where we are trying to find. It depends on the df, and the n become larger when the t is normal. So this is the equation for the t-test, and this is what we apply. I talked about before in the previous slide, I talked about df. df is the degree of freedom. In the concept of degree of freedom is the central principle of estimating statistics of the population from a sample of them. So the degree of freedom is commonly the abbreviation of df. Think of df as the mathematical structure that needs to be put into place when estimate one statistical form estimate of another. We're going to look at that in type of different data set and what we have. We have, for example, the standard deviation, and we have the idea of estimate the x bar and the s, and the formula for the degree of freedom is the following, where the x is the value of the population, the mu is the mean of all x's, and the n is the number of the x in the population, where we also have this the idea what is all together. So this is the degree of freedom. This is the idea of the formula in which the principles of the degree of freedom being used for the t-test. For the distribution of the t-test, the degree of freedom always has a simple function of the sample size, which is n minus 1. So one way of explaining df is the total or the mean of all but one score. So the idea is it is a fixed value that we often use. So a simple sample t-test is the following example. We have hypothesis H0 and H1, the alternative hypothesis. We have the value of S, we have the N, capital N 25, and this is where we come up with it. So we also measure the difference between the means, and by doing that we are able to see where the larger sample and the use of Z score into it, and the independent sample T when we are looking at that and apply to it. So again, those are the formulas, or this is the equation that we are using. So the dependent T, the dependent T, where we have some ideas of it and assumptions that we must take into account. So we describe here today the idea of design where it makes sense to use a simple sample test. We use to describe design that makes sense of the independent sample t-test, and we also need to measure the strength of the association with regard to what is it really means with regard to the purpose of predicting or explaining the differences that we will find. So the strength in this case and the association, the estimate of power, and the estimate of power in this case, and in R. which is probably where you're going to ask questions. And I'm sorry that my screen cut a little bit of the end value. You will see the last line in the PowerPoint presentation that I download for you. So the function of t-test in R is performing t-test. So we have to have the x and the y, and we are applying, in this case, R norm 10 and for the x and the y, and we are going to test the t-test between x and y. So which means that we are taking two sample t-tests, and in this case it will give you an answer of the value of the t, the df, the degree of freedom, and the p-value, in order for us to evaluate and to make sense what we actually found. So we need to have more ideas about that, and we need to have some sense, and I gave you this example with regard to what does it really means. So in this case, the value we want to name statistics. To extract that, we can use a $sign notation or a double square brackets. In this case, t-test $sign statist, and we will get the same thing. Again, we can do the same notation with two brackets under statistics in order for us to get the same result. So this is where we can manipulate the R in the t-test in R in order for us to get more accurate reading out of it in order for us to do it. How can we test if it's true? And again, this is the way for us to do it. One way is to plot it, and the other way is to do distribution. And again, the lines, and we are going to do that, the destiny of the TS, to apply the distribution of the data, and in order for us to get this result. So again, there's other way for us to do it. QQ is a plot that can show you the QQ function into it. I highly recommend that you use it. In this case, this is the QQ plot, TS and the RT. I gave some value it. I gave the degree of freedom it equal 18, and I gave a AB line into it in order for us to get something out of it like that. So again, I gave you explanation, I gave you the outline, what it really means in that sense and how to apply that. So we can also divide the data in quartiles, which means that if we are doing quartiles, we need to make sure that the 95 and 99% are quartile perform the same calculation when we do that. And so in this case, we apply alternative, which means that true difference by means is not equal to 0.95, and it means that we can calculate that. My mistake that I did not write here 90.5 correctly. This I took it from the R as it is, and so the idea here is again what does it mean, the 95%, and how to apply that into the context of the hypothesis, and how to apply destiny in R in order for us to apply everything together. And again, this is where we can come up with quartile and divided it into 50, 70, 90, 95, and 99% in order for us to do that. That's all for now. I will provide you in your Canvas. I did not prepare the Canvas screen yet, but I will provide you more information about what we have covered, the t-test for independence. I will give you more example and hope it will make more sense. Please ask questions. Your job in this class to ask questions, and my job is to answer. If I'm not doing it right, ask more questions so I'll be able to direct you to the right directions. Until next time, be safe of the hurricane, and I'll see you next time.